AJ built an AWS Access Review tool that checks 5 different security services and emails you an AI written report. I took his code, rebuilt the deployment in Terraform, and found out my sandbox wasn't even part of an AWS organization, which had me troubleshooting my very first run. Today, we'll cover what I kept from his original build and what I changed, an error that showed up before I'd even finished deploying, a place where the AI generated report got something wrong, real bugs I found while rebuilding, and a preventative check that stops bad policies before it ever deploys, and why I built this on someone else's foundation instead of starting from zero. Before anything else, this build stands on someone else's work, and I want that said clearly at the start, not mentioned once in the description and forgotten. AJ's Git handle is AJ0127, built the original AWS Automated Access Review project as a part of the GRC Engineering Club. It's open source and it pulls findings from IAM, Security Hub, Access Analyzer, CloudTrail, and organizational SCPs, runs it through Amazon Bedrock for an AI written executive summary, and emails the whole report out. I didn't build this from zero. I took his foundation, replaced his CloudFormation deployment with Terraform, and adapted the Python modules along the way. Full credit, his license notice stays in my repo, and his original repo is linked below. Go look at what he built. First real run, immediate failure. Not a bug in his code, a gap in my environment. AJ's tool reads service control policies through AWS organizations. It assumes you're already part of one. My sandbox wasn't. Most personal sandboxes aren't. His code was right. My environment just didn't have anything for that check to evaluate. So before I ever ran my own build, I already knew what to fix first. Instead of skipping the SCP check, I stood up a real minimal organization for it to evaluate. A single account, one organizational unit, one demo SCP, deny root user action, small enough that Terraform destroy cleans it up completely. No member accounts ever attached. Nothing left behind. Now, the SCP model has something real to find instead of silently skipping it. One IAM role, scoped read-only across 5 different services, plus exactly 2 exceptions. IAM read-only, organizations read-only, Security Hub read-only, Access Analyzer read-only, CloudTrail read-only. The 2 exceptions are Bedrock Invoke, so the Lambda can generate the narrative, and SES Send, so it can actually email the report. Nothing here can change a single setting in the account. It can only look and report. Lambda timeout went from a default 30 seconds to 300. It's checking 5 services now, not 1. Memory bumped to match AJ's original configuration. Same read-only discipline as the rest of the series, more surface area, same guardrails. The Lambda doesn't just collect findings. It hands them to Bedrock and gets an executive summary back, in plain English, ready to forward to a stakeholder. I fact-checked this against the real finding, line by line, but before trusting it, testing surfaced something specific. The model performed unrequested or math on a finding, stated age, and reported the results incorrectly. Not a hallucination fact. The model doing math it wasn't asked to do and getting it wrong. So I added a guardrail directly in the prompt. Report the findings age as given. Don't recalculate it. An AI-generated report is a draft an auditor might actually read, not a document you forward without checking what it did to the numbers. Rebuilding this in Terraform surfaced 3 things worth talking about. The SCP check searched a policy's entire serialized JSON as raw text, looking for the substring IAM. Problem is, that matches inside unrelated text too. An ARN, like ARN, AWS, IAM root, trips it, even when nothing's actually protected. AJ's original code did exactly what it was written to do. Substring matching is just a simpler method. It tightens it to parse the real action fields of deny statements against actual service action prefixes. 2. Same category. Why permission detection flagged a user as admin-like by checking whether the word admin showed up in a policy name. A policy literally named, say, admin helper with 0 real permissions would be a false positive here. While something quietly named with full access would slide through uncaught. I swapped this for fetching the actual policy document and checking the real statement. 3. The AI narrative's fallback logic had a nesting defect. 2 fallback functions existed, one detailed, one generic, and the generic one always won, no matter which error actually happened. I consolidated it down to one fallback that shows the real finding data and the real error. All 3 are documented in the repo's third-party notice, so anyone can see exactly what changed. I didn't build this from a blank file to prove I could do it solo. I built it on AJ's foundation on purpose. That was the actual challenge I set for myself. Reading someone else's real published working code, tracing exactly how 5 services fit together, hitting a real environment error before I'd even finished deploying, working one real bug down to their actual cause. None of that happens without a tutorial or a blank file. It only happens when you commit to fully understanding work someone else already shipped. This was actually my first project in the GRC Engineering Club. And I want to be clear about what that means. AJ and the club weren't walking me through this specific build. The foundation they gave me was just solid enough that I could reverse engineer it and build my own version entirely. That's what a good foundation does. If you want to actually learn to engineer, you don't always have to start from zero. Find something real that actually works and challenge yourself to understand it well enough to make it yours. Everything so far detects problems after they exist. I wanted one more layer that catches some of them before they're ever even deployed. This uses Access Analyzer differently than the Lambda does. Not scanning what's already live, but running valid policy against a Terraform plan in CI before anything ever reaches AWS. Every pull request that touches a .tf file, GitHub Actions builds the plan and checks every IAM policy in it. Find something overbroad, the check fails right on the PR before I ever even merge, let alone apply. First time I opened this PR, it failed. And this time, not because of my own setup, the check caught a genuine valid AWS best practice finding. My demo SCP used the wrong condition operator for an ARN type condition key, string-like instead of ARN-like. That's a real common IAM policy mistake. String-like does plain string matching. ARN-like is built for ARN patterns with wildcards. Fix the operator, push the fix, watch the same PR turned green. A detective control after deployment, a preventative one before it, and this one didn't just pass once. I fixed my own setup. It caught something real. AJ's tool, my sandbox, an error before I'd even finished deploying. And now a real organization, a real Terraform stack, 5 services reporting in, 1 real bug found and fixed along the way, a CI check stopping bad policies before they deploy, and an email in my inbox with an AI written summary I've actually verified myself, not just trusted. Subscribe for weekly GRC and AI governance market intel. AJ's original project is linked below. Go look at what he built. It's a genuinely strong foundation, and this video doesn't exist without it. My rebuild is linked right there too. The Terraform, the fixes, the CI validation. If you want to see exactly what changed and clone it yourself, tell me in the comments. Have you caught an AI generated report saying something that wasn't actually in the data? I want to hear about it.